Good afternoon. Is this working? Yes. Oh, geez, I can't tell from here. It wasn't loud earlier. Oh, better. Okay. So IETF 104. This is the GROW meeting. If you're not supposed to be in the GROW meeting, it could be fun. You might want to stay. John Scudder's here.
Oh, you got the special room.
We got the special room with John again. I'm Chris. That's Job. That's the other half of the room. Wave to them. Hello. Okay. Told you it'd be fun. Yeah, they are remote, sort of remote, semi-remote. Okay. We have 2 hours. We have not 2 hours worth of presentations, so we should be able to take our time and have a good conversation. For those that are giving presentations, please, the mic has to be close to your face. If you do this, no one can hear you. Must keep the mic in front of your face. Here's the clicker. It has a left and a right. It has a laser. All right. As operations folks, we know not to look in the laser. Okay. All right. Here's the note well. Everyone's read that. Good. Okay. List of resources. Also, get out your binoculars for that. All the slides, I believe, are uploaded. If anybody is presenting and has sent me slides in the last 20 minutes, sorry, they're not up there yet. We have blue sheets which are going around. Please sign them so we get a better room next time. Bigger room. Well, the column is nice. I don't get to see those people. Or they can't see me. We have a Jabber scribe already. Natalie, is there someone who would like to take minutes? Awesome. Thank you very much. All you have to do is email them to Job when the meeting is done, or to Grow-Chairs. Do we have anything else to add to the agenda?
Is there one Timothy Hollebeke in the room? No? Okay.
Nope. Okay, that's it. Great. So we have, are you Timothy? No, you're not. We have six drafts. These are all progressing along. If the authors have questions about them, 5 of the 6 are progressing along. Those, if the authors have questions that they would like to raise, you could jump to the mic or you could email the list. If you want to move on to working group last call, you need to email the list to let us know you'd like to do that. The last one on the list, Mr. Scudder's Grow BMP Peer Up. Do you want to say anything about that, John? Oh, okay. So we already adopted it? Okay.
Sure. So no, we didn't already adopt it. I misread the slide. Right. That is something I would like us to adopt. I don't have any slideware on it. I sent mail to the list about it a couple months ago. The very short outline is that the numbskull who specified BMP stuck TLVs in some places and not in other places, and didn't really manage the namespaces very carefully, so some of them overlap and some of them don't. And this is an attempt to sort of untangle the namespaces. Anyway, I think we should adopt it. It's not very long. Give it a read and, thumbs up or a thumbs down. If it's a thumbs down, it would be really helpful to have a suggestion for, a different approach, even if we like tangled namespaces. Please leave them alone, John.
Thank you very much. We can take up all of your complaints with Stephen Stewart. Okay, so we have 5 presentations. The first one is the NH scale-up peering. Rafael. I'll also stand on this thing. Yep.
Thanks.
Oh, man. You're going to have to lift it up. That's why I was holding it, because it won't go where it was.
Okay. So.
Oops. Oh, hold on. You know what? Getting your presentation up would help, wouldn't it?
Yeah, that's the thing.
All right.
The longest one.
Longest one. All right, good. All right, now.
Okay. So I start from the back. So the scale-out peering, what it is, and short background. It comes from real challenge from the field. The scale-out peering is the case when the set of ASBRs are peering with the one or more ASBRs in the PRAS. So with the hope to have the load balancing. So that's a core of doing that, right? The reason is to have the bandwidth and +1 redundancy. Doing this without impacting the entire network on the scale of states, and of course, everybody likes fast restoration. That's just for reference. There is I will use this concept during the presentation. So there is a site when we have the ASBRs, but also some co-routers, some red reflectors optionally. In the network, to describe what is the proposal, we use, it's a native IP network. We use the add path, multipath whenever necessary. And during the deployment or testing of that, we found that the classic approach to the handling the BGP next hop has some shortages. So one is that next hop cell doesn't allow us requires us to withdraw path by path in case of the external peering down. Nothing specific except it's slow. We can speed it up when we use the next hop unchanged, but then first of all the session could go down, interface not, and we are back to square zero. And then even if we not consider that, there is some transit traffic move to other side and back, we'll try to avoid. So that's how the abstract next hop comes to life. There is no prototype changes. BGP operates as it operates. It's just how we use existing mechanics. It's a /32 address. You just pick it from your space. And we use it as a BGP next hop with an internal advertisement for the path which are received from one of given subset of eBGP peers. And we insert this address into the IGP because we need to resolve the BGP next hop, but conditionally, only if at least one session from the set is in established converged state. And what is this subset of eBGP session? It's a little bit of it's operator decision. In example, it will be a session with the given PRAS, but you can change it. Concept is quite general. There are other possible uses, but we go with that. So first of all, how this works, we set up the abstract next hop, which is specific to the ASBR and the PRAS, because that's our choice of defining the session set. That means that on the site route reflector for external routes, we have, I'm sorry, Job, I may point your eye. Oh. So then, of course, on the route reflector, we see all paths. So we have 4 paths per prefix in this example, and this is distributed to our core routers. Nothing really specific. There is a 5th path as well for backup purposes. That's we will see this soon. And then this allows a core router to load balance traffic to all ASBRs. So far, so good. I have some failure case slides, so I hope we can go to that. what is happening out of the site, I don't want to propagate all these paths because I want to hide the fact that I have so many ASBR. One of them is better. One of the paths will be selected as active, but I need to compress the number of states. So there is another abstract next hop, and this abstract next hop says, okay, this is new address. And I use it for all sessions with PRES, regardless of the ASBR in my site. So it's a site specific. And root reflector advertise just one path. At that point, from the network-wide perspective, regardless of number of ASBRs here, I see only one path saying there is an exit through this site. That's it. And again, because this is next hop, I have to insert this address into IGP. I do it conditionally, saying at least one of the session has to stay up to advertise this, to have this address in IGP. Some failure cases. So if my one session goes external session goes down, nothing changed because there is other. So no changes in the control plane from the next hop perspective. If I lose this one session with AS3, then there will be next hop removed, one of the next hop removed. All session with AS2. So that's a kind of doom scenario for this site. For this ASBR. So I lose the ASBR, but there are remaining three. So these two guys are still able to load balance traffic between remaining three ASBRs. And now all session on all ASBRs at the same time. That's a doom scenario, sorry. Then we remove all the abstract next hops. So we need the one more, but this is one site specific. So we have the backup from the other side. It doesn't remove the need of withdrawing path, but it allows to react on this failure before the path are withdrawn, just based on the unavailability of the BGP next hop. And this, if somebody used the peak edge, it just triggers the peak edge. Similarly, how this, oh yeah, you're right. You are right. So we have to fix the PDF. We have some artificial links there. So same with the AS-wide operation. One session, no changes with next hop. So even we may need to send the update because some attributes changes like originator ID, but it's as the next hop doesn't change, the forwarding plane not need to be reprogrammed, so the traffic is unimpacted. The same with the one session with the other AS. All session with one of ASBRs, no changes. Only if we lose the all session from all ASBRs, then the site lose the connectivity with the AS2, so we can recall from IGP the site-specific abstract next hops, and then traffic will move to the other side, not shown in the picture. In summary, if you go with the scale out for the peering, that allows you to. We are doing that for the boundary, for redundancy, maybe for round trip time reduction, at the cost of scaling up the control plane states. So we need some constructs and practices in protocol configuration, network design to counter that. Abstract next hop or conditional next hop or whatever you want to call it is useful, and we can use it to control this BGP scale, as in this example. Next steps, I need more feedback. Thank you for Robert and Ron. Robert actually gave a good feedback that in the draft, the abstract next hop is tracking the state of the BGP session, but we can make it more generic and track other objects, which is true. And I think this should hit toward informational document. We are not defining any new standard, it's just sharing the practice. Thank you.
We have some time for questions. I have one question myself. Is the applicability of this meant to be within a single administrative domain? Or are you referring to actual eBGP with other administrative entities?
So from the AS perspective, we can use similar thing between ASs, but it's rather one administrative scope. I didn't thought through doing this across internet and the total independent operational organization. It should work because we are not changing BGP, but we have no IGP, right? So just one comment. We have some thought how this could be applicable in the data center clause when we use the eBGP between the spine, leaf, spine of spine, etc. It's possible, but then we have to resolve BGP over BGP, and then we can reduce have the same benefits.
Ignas Bagdonas, it's a thinking aloud and more of a comment and less than a question. So what you describe here does not specify the protocol, neither changes nor protocol interworking. This is more of applicability, in a sense, how do I build and run certain things? So the question that I have is, what is to standardize here then? And whether the RFC as a format is the right format for such type of information. The fact that it describes a practical and applicable use case, yes. Whether there's work for IETF to do here, I would say an open question.
So this is a question to me or to...
think of it as a loud thought.
Okay.
Well, we have something similar with BGP PIC, which also specifies how a certain element operates, but not necessarily how it interworks on a protocol level. That's more of a local implementation and local configuration aspect.
Yep.
This probably is also in the same direction. And
please.
So I'm just stating a thought, an open-ended thought, and hopefully this will start a discussion.
Thank you.
Ron Bonica, Juniper Networks. Responding to your question, I think informational is the correct category here because we're not standardizing anything. It's just an operational insight, and an operationally leaning working group is the right place for it to be.
Thank you.
All right. Thank you, Raphael. I guess I'm next up. Oh.
Job's next up.
Or Paolo.
Oh, or Paolo. Fine. Demanding. Let me get your slides.
Hello? Hello?
Look around.
Hello. So it's Paolo Lucente, NTT Communications. I claim your usual attention for 5 minutes to provide an update on the Lockrib and Adribaut drafts. And maybe I can also use the pointer. Yes. So just a couple of slides, as always, to recap that it's now with this meeting, it's 2 years that we started this effort. It was in Chicago in March 2017. And the draft would like to expand the functionality of current BMP from Adri being pre and post policy to more a vantage point lock rib, add rib out, pre and post policy. And there is a number of backup slides to give you the whole context if you missed the start of the whole conversation. There was a lot of interest, pretty much I would say no opposition, but we received feedback and it was processed. And as far as we know, we authors know, there is no outstanding feedback, no outstanding action points from us at the moment. And since the last IETF, just a couple of things happened. I processed feedback from John Scudder about lock rib. He noticed that he was very right in saying that the peer down doesn't have a TLV section. So the same use that we had for the TLV, what we wanted to optionally TLV, we designed it in a way that there is a new reason code, and the new reason code can have a TLV information. And add rib out, it was really few minor wordings that was changed over there, including there was something that was saying was sent, information that was sent. So it was kind of, could have been misread, like the router that sent the information where it has being add rib out. It's, where the peer, where we are going to send this information. So there was changed into an is. And that's it. Maybe more interestingly, I would say this is maybe the most juicy slide. So I start from the bottom. So I still think that this effort should be wrapped up, should be let it go, and we should move forward. There was this aborted attempt at last call end of last year. I don't know after an aborted last call what happens, whether you can have a second attempt at a last call, I don't know. But then going to the top of the slide, really there was a lot of feedback also in Bangkok, right? So in which essentially, especially about the lock rib, what lock rib means, right? So shall we involve, looking at the fib in any way and things like that, yes or no? And I think I was already providing some clear feedback back in Bangkok. So I will just stress it once again to be, sure we are all online, in line with that, all in sync with that. Is that I think from the hallway discussion that we had, there is no right or wrong way to do it, right? So there are use cases for just looking at the lock rib, and there are other use cases to involve the fib. But for this very specific draft, we authors, we would like to stop at the lock rib, because then looking at the fib, there is a lot of things that can happen, which are vendor specific. There is a lot of layer 1, layer 2 underlay. Maybe also the vendor is not in charge, in full control of what happens at layer 1 and things like that. So in other words, there is a can of worm that we prefer not to open. But that doesn't mean that it should not be opened. So maybe to serve all the use cases where it would be great to know about balancing, hashing algorithms, lag, and other things like that. Maybe there is a space for a different draft, right? So, and maybe, I would be also interested in contributing to that. So, that very timely, I'm finished essentially. So that was maybe the most key and juicy point over there. So any comments?
So, Jafaz, Paulo, just for clarification on that slide, when you say fib, do you actually mean fib or do you mean active route?
Yes, I would say that I mean both, actually, right?
Not the same thing. So
Yes.
So this is a case where you just maybe not intending to be precise about the detail.
Right.
And just 2-sentence summary of why this ends up being important for things. Ignoring what the forwarding state that gets installed,
Yes.
The BHP abstractions do talk about how do you get other non-BHP routes in and out of the
Yes.
system. There's use cases for knowing what the best BGP route is. That's effectively it's the current document, and that's what we're sort of converging the text to.
Mhm.
There's also cases about figuring out when you have those other routes in the system, which one you pick to advertise on an outbound basis. So
Sure,
that's
sure.
that's the single point of contention here.
Sure, absolutely. And one feedback wanted to be that if there is something, I don't know, still unclear in the texting, in the text, please, we would.
I owe you additional comments, but yeah, for the room, that's basically what our conversation sums down to.
Sure.
Hi, Igor Roshinsky, Yahoo, Oath, Verizon Media, whatever name is yours. I think this is way overdue. We desperately need this. Many of us are building other ways of collecting this data via streaming telemetry, and it would be really nice if there was just a lock reb and edge reb out of BMP. So yes, please, how do we help? And also for the fib thing, that is also becoming very important because almost all magic God boxes in the sky need to know the fib in order to even calculate what's actually happening. Because very often the RIB might have a lot of stuff in it and you don't know what's actually programmed to the hardware state. So if you need any help with text or whatnot, I'm sure there's quite a few people in this room, probably including me, that would love to help with that.
Absolutely. And so first of all, I agree with everything like that that you said, and I think that one of the, for example, one of the at the very beginning when we started presenting these slides, one of the things was precisely that there was no unified way to get all the vantage point with a single protocol. So people should resort to 2 or 3 different ways to get all the vantage points, like adrib out, adribbing, and lockrib, like BGP, BMP, and maybe streaming telemetry for adrib out, or maybe CLI screen scraping or other things. So in the end, I agree.
Architecturally, one big issue with having multiple ways of collecting the data is that usually they're not in perfect time sync.
Yeah.
So if you have a single protocol that can actually export both edge ribbon, lock rib, edge rib out, and lock fib, you could actually see when devices misprogramming for whatever reasons or how long it takes for a device to program.
Yeah.
You could do a lot of correlation that you couldn't do if you're working across multiple protocols, in which case you have no idea of the delays because of the streaming infrastructure, collection infrastructure.
Sure.
There's no correlation as opposed to within a single protocol there is, which is why most of us would prefer it to be a single protocol.
Sure. Fantastic. Thank you.
So how can we help you move this forward?
I think we should talk after this.
Okay. Thank you.
Jared Mach, Akamai. I'm also interested in basically plus oneing almost everything that Igor said, seeing what's actually seeing everything, not just necessarily what came in adrib in or adrib out is helpful. Thank you.
Sure. And I myself also do a +1 to your comments as well. Yes. No, as one of the co-authors of a draft, I think it was in IDR, already forgotten from 2014. There was this effort in which it was called BGP path marking, something like that. It was one attempt at trying to describe, the problem that people have in understanding what is an active path, which are the active paths, because you could have add path and maybe you have active paths, and you could have multiple active paths, but not all the ones that you see are active. So there are others that are not active. And essentially that draft didn't really get much traction and support. So actually I have interest in what Jeff was saying before. So the active path, I have interest also myself in the fib. So I would be glad to join a new effort about that. That's it.
Commenting on the process, reviewing the adjacent RIP out draft, it passed working group last call. There were no objections to move it along. And related to lock RIP, Jeff indicated he owes you some comments, but I also think that John Scudder has an outstanding question for him, because you made some changes to address things that were brought up, and we never saw a reply whether that's addressed the concerns. So if these two gentlemen can take a look at lock RIP, we can maybe move it along or update it.
Sure.
And we'll get adjacent RIP out moving along.
Sure. All right.
Thank you, Paulo.
Yeah.
Good afternoon. I am Job Snyders from NTT, and I would like to talk a little bit about maximum prefix limits in context of BGP. Some of you may know what the purpose of maximum prefix limits is. They are a safety mechanism where you can configure a high watermark, and if that threshold is exceeded, the system can shut down a eBGP session in order to protect the innocent. And the assumption here is that the system is blind. It doesn't know anything other than that if too many routes are announced, something somewhere is wrong and it's safer to self-destruct. And this applies specifically in context of internet routing, usually related to full table route leaks. This is what happens when maximum prefix limits are applied pre-policy. And the original BGP core specification talks about maximum prefix limits, but it was not defined in a very clear manner, in my opinion, because there's different types of prefix limits. If we look at this image from left to right, we have the passing of time. From bottom to top, there's the amount of routes being announced over a given BGP session. The steady state is a set of routes that are expected to be announced. The operator or automation system made an error and a leak starts to occur, so more and more routes are announced to the neighbor. At some point, the threshold is met, the session is torn down, and from that moment on, both networks are protected against the consequences of this leak. And this is the desired situation. However, if you apply maximum prefix limits post-policy, after you've gone through all filtering techniques such as origin validation or peer lock or whatnot, there's a vastly different image. Again, from left to right, time, from bottom to top, the set of prefixes announced over the BGP session. We have the steady state, that is what we normally expect. Then there's a set of routes that are invalid but made it through the filters because none of our BGP filters are perfect. And then there is a set of routes that did not make it through the filter because of a high quality filter. And this may mean that a full table is being leaked, but the maximum prefix threshold is never met because the filter only applies post policy. And that means that for a long duration, until an operator manually intervenes, there will be a set of invalid prefixes going through that BGP session. So it's a bit asinine that despite our attempts to construct high-quality filters, it negates the effects of maximum prefix limits that are intended to counter full table leaks. There are different applications for pre-policy and post-policy maximum prefix limits. The pre-policy maximum prefix limits predominantly exist to protect against memory exhaustion, because if you have to store everything in adjacent RIP in, and you don't place a limit on that, then somebody could, for instance, announce millions of routes to you. And pre-policy is very effective against full table leaks. Then the post-policy maximum prefix limits can help protect against, for instance, FIB exhaustion, if you have a device that has a limited amount of FIB space. Also RIP, local RIP exhaustion, or to enforce contractual agreements. You sometimes see this in the context of layer 3 VPNs. So both have a right to exist. We made a small inventory of what the current state is across the vendors. And I would, for instance, like to talk to the people from Cisco after class about why there is no pre-policy maximum prefix limit. I've also added a column here, outbound. I think, speaking for NTT, it would be very useful if we can self-destruct eBGP sessions when it crosses, goes past thresholds which we know should never be met. For instance, on a given moment, we should be announcing roughly 300,000 routes to level 3. If we're announcing 600,000, I would like to tear down the sessions because whatever is happening, it's not according to our expectations. Out of the vendors, only Bird has implemented a outbound maximum prefix limit. So the purpose of this draft is that we want to describe what types of maximum prefix limits exist, where they fit in the conceptual BGP model. We describe how outbound maximum prefix limits would work. And then should this become an RFC at some point, it can be used to communicate through RFPs with the vendors where we can point at this is the specific feature we would like. In addition to a real self-destruct where you tear down the session and send a cease notification message that the maximum amount of prefixes was hit, there are other options to deal with this failure scenario. For instance, you could withdraw all your routes, or you could stop announcing new MLRIs, but I consider those out of scope for this draft. Vendors are free to implement advanced forms of high watermarks, but I want a sort of baseline that is specific for internet routing. So we have a draft. I would like to ask the group to consider it for adoption, and then we can continue the circus. Let's see. I think that's my last slide. So with a few minutes left, I would like to open up the floor for comments, concerns, questions.
Chair Akamai, yes, please. I would be happy to help you in any and all ways on this. I would also be happy to help you ask the vendors as well as part of the implementation piece. So if you currently are trying to sell me stuff or I am buying stuff from you, you will be hearing from me, especially on this outbound issue. Because the outbound issue has definitely bitten us several times and is the type of thing that is going to become required in equipment that we would purchase from you. And it is really important for us to ensure that that happens to help protect ourselves from ourselves, because sometimes we happen to be integrating a lot of networks together, and that is creating the likelihood that we have many of these things that will be an issue. Thank you. But I'm happy to help you author or anything on this.
Look forward to working with you. Thank you.
Yeah, Kanami Ishizuka from NTT. Yes, I support this draft. Passing through the massive prefix to the other ASs can expand the damage of route leak. So in order to protect the weak routers, this maximum prefix limit in outbound is required, I think. So I support this draft.
Thank you.
John Scudder. So partly based on experience with, first of all, I think this sounds like something good for the group to work on. So great. Sort of battle scars from RFC 7606 speaking, I would like to suggest that you reconsider your decision to ask your vendor to be creative about what to do when your outbound prefix limit is exceeded. I'm relatively certain that if vendors implement that as self-destruct, as you put it.
So with self-destruct, I mean that the session is torn down, a cease notification is sent.
Yes, I know that's what you mean.
And that's the only implementation I want to describe in an RC.
I would like to suggest that you reconsider that, because at least we can have a conversation about it as a group, because the reason that that's a reasonable thing to do inbound is that it's really hard to do anything sensible other than tear down the session once you're out of resources. Outbound, you can probably do something more sensible. Given that you probably can do something more sensible, I think that it's likely that now putting on my vendor hat, that my annoying customers will come and ask me to do something more sensible. And when that happens, maybe it would be nice to actually have thought through this, as an industry, instead of having every vendor do a different, arguably sensible thing. We can continue the conversation, later, since there's a big line.
I look forward to discussing this in depth. If I think I can spend 30 seconds.
Jared Mach, I asked permission to cut from everyone individually. I do agree with John Scudder in that we should document a standard way to do this, and it can be it absolutely can be a knob, but in the outbound, we would probably want to just reduce withdraw all advertisements in our operational use case. Thank you.
Why I, at this moment in time, would prefer to destroy the session is if you look at how the operational lifecycle is when there's a fault in the network. If the BGP session remains up, that silences some alarms on both sides. If you, for instance, stop announcing new routes, not only can we arrive in a situation where there's inconsistent views in parts of the internet table, but the link will continue to pass traffic. And for instance, NTT monitors for links that are not passing traffic that should be passing traffic. So I feel that by shutting down the sessions, a lot of subtle hints that maybe trigger other processes in the organization can be leveraged if the syslog message is lost or was never read. But we should discuss this. I have my view on this, and I'm happy to be convinced otherwise.
So Igor Vyshinsky, all those affiliated organizations. I agree with Scudder and with Jared. It sounds like we need a set of options for what a vendor could do that would be sensible. For your network, the sensible might be tear down the session. I suspect for most network, the sensible thing to do would be to tear down the session and generate some message to the far side that they could understand why the session was torn down. For my network, for example, no withdrawal routes. I do not want you to tear down the session because I do have instrumentation that will detect that I'm advertising zero. Other people may say, only send this golden list, this other prefix list. Maybe that's what they want to do. I think this definitely is a discussion that needs to have before we mandate do this, and then we have a BIS document that updates it. But I do absolutely think that we need this. But if we implement this, can we make sure that this limit is post policy? Because I feel that needs to be highly specified.
The outbound maximum prefix limit is post policy.
I think that needs to be. Yeah, it's not on your slide. I think it needs to be explicit because I'm sure somebody very creative will implement something like this pre-policy.
I don't know how, but
it's possible. So let's.
The intention of this document is to make it very unambiguous how these mechanisms work, and that vendors can say we are compliant with this, and this type of.
But we absolutely want this. But I do think that we do need to have an agreement on exactly what options are, because having a BIS and a BIS to a BIS would be bad. So thank you.
Thanks.
Okay. Rüdiger Volk, Deutsche Telekom. What I think should go explicitly on the list of features to check is, does the implementation of the session termination on overflow inbound actually include the information about what limit actually was hit? because
In the cease notification message, you can include the number that was hit and the API.
yes, kind of you can, you should. Okay. I'm slightly more polite. Being a little bit less polite, the creativity that John is calling for may open ways into insanity. Be careful what you want and what you do. And I don't expect insanity from John, but I could imagine other people really doing weird stuff, and also customers asking for specific creativity that is insane.
Thomas Graf, Swisscom. Outbound prefix limits, yes, please, but please go one step further. I would like to see...
Blow up the router?
No. Very easy in the capability exchange. I would like to understand if there's an inbound prefix limitation. I would like to learn it and not sending more routes than they are accepting. And also this can be reused on BMP, so I can see basically how much routes they would accept, and I'm not sending more than what they accept.
If you're interested in that specific feature, Marco from PCCW has a draft in the IDR working group that communicates a maximum prefix limit through an ORF mechanism. So if you want to pursue that, find that draft.
Okay, good, thanks.
Jeff Oz, we already talked about using the notification shutdown to pass along, the why you shut it down. I got to throw out a little bomb and then walk away. This is potentially a good time to bring up the Twitter over BGP thing that we talked about in the past. The admin messages is a perfect way to carry this stuff. What that feature actually meant was very contentious. I'm not going to talk about it anymore. Think about it.
So, Warren Kamari, first with no hats. This sounds grand. Now, with the AD hat on, you should probably mention this on the IDR list. I don't see how they could fuss, but it's worth just making sure that, they're informed and they don't come along at the end and say, this changes the BGP state machine, grumple.
That's good feedback. I think this draft may update the specific section from the BGP core specification that very briefly talks about maximum prefix limits and then extends it into this is a more precise definition in the conceptual model. But we can talk about that. Final comments?
Hi, Laura Rodana. If we're changing state machines and all that stuff, maybe this should be an IDR. I would hope that you guys talk to John and Sue and agree on where to do this. I'm fine if it's here, as long as there's some agreement there.
It's good feedback. I will talk with them. Thank you for your time.
Juan? Should I do them in this order? Where's that? Oh, sorry. Like our hog.
Hi everyone. This is Yunan Gu from Huawei. So the first draft I'm going to discuss is BGP root policy attribute. That one.
Perfect.
Okay. So nowadays, already BMP. Okay. So BMP already now monitors pre-policy and post-policy ribbing and local rib, and also pre-policy and post-policy rebound. So operators, they can use the different versions of the ribs to find out if there's something wrong with the configuration or policies. But it's hard for them to know which exact policy causes issues if the rib doesn't work out as they have expected. So this document proposes a method of recording the correlated root policy with root attribute change. So here's a very simple example to show how you record the correlated information. So the key will be the prefix, so you know which one, which prefix you want to monitor. And then there will be different events. So each event will refer to a root policy processing. So you'll have the policy name or policy ID, which we'll discuss a little bit later. And then you'll have the timestamp. And following that will be the root policies. Okay, so sorry. So by looking at these events in order of time, you'll see which exact policy is responsible for the root attribute change. Okay, so it can be used for things like policy validation and also troubleshooting. Yeah, so we're proposing a new message type of BMP to carry this root and policy information. And here's the message body looks like. Okay, thank you. And we're only using the BMP common header where the message type will indicate a new message type, which is to be assigned. And we're not using the prepare header. And this is the message body. So it consists of the following parts. First is prefix information. So here you indicate which prefix you're monitoring. And then you have a previous hop field in here, which is used in combination with, So this previous hop field in here is used in combination with policy distinguisher here, okay, which I'll explain a little bit later. And then after the prefix information, you will have a count of the total events. And then following that will be the information for each single event. First, you have the event index for each event, and then the timestamp, and then following that will be the policy information. So it consists of the policy ID and policy distinguisher. Here we have only, so far have only defined two types of policy distinguisher. One's the inbound, the other is the outbound. So more could be defined later. And following that will be the peer information. So which exact peer the policy is configured under. So suppose if the policy is not an inbound or outbound policy, for example, it's an import policy, then the peer information could be the local information. Okay, and then after that will be the VRF and address family information, and then following that will be finally the BGP attributes. Okay. Okay. So yeah, one more thing. The previous hop field here. If the policy distinguisher refers to the outbound policy, then this previous hop will be indicating where this prefix comes from. For example, two peers are advertising the same prefix, and then this field will tell you which exact peer this root is selected from. Okay. And then here's a simple example that we show how to use such information to recover the root propagation. Sorry, the root propagation within the network. So, sorry.
Does anybody have water?
I'm good. Thank you. Now suppose CE1 is advertising a prefix to PE2, and also the same I don't think this will work. All right. But I really do need water. Thank you. Thanks.
We have time. Thank you, Jared. More water here.
Okay, so the same prefix is advertised by CE2 and CE1. And after received at PE1, it selects the route that comes from CE2. So for PE1, 3 events will be reported. First one is the inbound event from CE2 and also the inbound event from CE1. And then it also reports a outbound event, which indicates that the route I advertise to the route reflector is the route that I select from CE2. Okay, and stuff like that. So with the event and also the timestamp, I think the server is able to recover the trace of the route propagation. And that's just a simple example that you can use to do well, well, it's just a simple example. You can do more things with such information. Yeah, route policy, validation, troubleshooting. Yeah, and that's that for this draft. Any comment?
Hi, Jeff Haas. We started a little bit of this conversation at IDR,
Yeah.
Partially for context for other people that should go look at another draft. Jacob Heitz did one for doing tracing for events using timestamps and trying to stick that in the BGP. In this case, we're trying to stick stuff in the BMP. The good things, we're getting 3 of our route types stuffed in one message. This is handy for correlation.
Mm-hmm.
The policy that's being referred to is presumably the matching element that's the reject or accept in your policy.
Mm-hmm.
Unfortunately, in a lot of cases, and Rudiger will speak more to this, I think, since this conversation did come up a couple of IDR, a couple Grow sessions ago about could we actually put something inside the BMP to say why the route was accepted, rejected, etc. And it's a good thing. This is a good example of the thing that we would like to do. The problem is that if you think about the types of things you're trying to trace, like pick BGP communities as an example, they could be changed on import from what they were learned as, they could be changed as part of leaking them between internal routing tables, and they could be changed again when you actually advertise them in the outside world. Policy is a giant program. So if you want to actually try to trace a program, you do sort of the equivalent of adding print statements at the places where things happen. To some extent, I think, so the thing that's trying to be solved here is good. We're trying to actually trace what happens to the route. We probably want something more like tracing a program. So basically print statements on whenever you make an alteration to route properties. You want to keep track of that. You probably don't want to take that giant list of output, even if the idea of how do you record one spot inside your policy, like inside of your draft is the way we'd want to do that, into BMP itself. Just simply because you couldn't keep enough state in the route in your routing table to sanely store this. So I'll make the same comment I made to Jacob when he was talking about timestamp and sticking this in BGP, that messes things up. Here, if we wanted to keep the interesting stuff, that full list of things that we've changed, not in BMP, maybe we take this problem space and move it out of BMP and move it to telemetry. So you instead, I'm sorry for completely changing your proposal, just trying to talk through the problems that we have with just a single item. If it becomes something more like telemetry, and like your draft does say, you're not looking to do this for every route in your table. Doesn't scale nicely. It's good for tracing specific things. And
right.
Telemetry means that you can tell your routing system, router by router, please watch for this prefix to go by and send me this debug information when it passes through the system. And a central collector can still pick it up. Not saying there's not a huge amount of text that we need to do to define this sort of thing, but I do think that telemetry might actually be better solution space than BGP.
Thank you for the suggestion of considering telemetry gRPC as another option. And I think it's an optional approach to do that, but I can't really tell which one's better right now. But I think it's possible. It's worth discussing. Yeah. And another thing I forgot to mention, sorry. Here, the policy ID part. Well, I want to clarify that the policy ID here is not the policy itself. It's just an indicator that you can use to map to your actual policy. Okay, the policy you can use gRPC. Doesn't matter to export. Yeah, and
yeah. So again, the comment is a little less upon the things that this is still useful. This is sort of the exit event from the policy engine. And that still has some use, but to pick on certain providers that I happen to know.
Are you talking about the timestamp here?
Not the timestamp, the actual code. So I'm saying I have accepted or rejected this route at policy foo, line 100 as an example. That's one thing that you can do there. But pointing to any number of providers that are in the room that I'm familiar with some of their policies, the chain of policies will often end at a common set of conditions that just say yes or no, and doesn't give you a hint as to how the route has changed over that course of things. So to some extent, I'm not arguing this isn't useful. I'm saying this is, the barest level useful. Maybe we should do, the more complex thing.
All right. Thank you.
Thank you.
Rüdiger Volk, Deutsche Telekom. What I'm seeing is there are quite different questions that come up in the problem space that you are addressing. And depending on the questions, probably different tools and different logic is appropriate as a solution. One thing that Jeff was mentioning, and I would make kind of explicit, for really inspecting how. Well, okay. One could think that, well, okay, tagging information onto regular BMP streams essentially would match very easily and nicely if you create additional information for one pass through either an ingress or an egress policy, and completing the whole journey through it. Usually something happens that will actually produce a BMP record, and tagging a little bit onto that, addressing or giving information that you are interested in is nice. Using the BMP for essentially doing a single stepping through one policy, which may be 150 lines and 70 or 80 different conditions, does not look like a really feasible idea. And yes, it may be quite interesting to ask a router vendor to implement such a single stepping thing, like in the old times when we were doing assembler programming. We used the single step, and in certain cases, that was the only way to actually figure out what we had programmed. Well, okay. Unfortunately, once in a while, we happen to program in the wild in BGP policies that are as stupid as we were doing stuff back in the old assembler days.
Sorry.
Huh?
Sorry.
The thing that I have been asking for in this area actually is trying for my use cases to scale things down, and kind of what I am asking for is, well, okay, please give me the opportunity to tag on the drop root primitives, an optional exit code, so that I can mark for which of the 25 reasons I will reject customer routes. I can actually mark why, well, okay, what was the first criterion that made the route unacceptable? Because at some point in time, I want to create reports for the customers to tell them what's wrong with the stuff they are sending. And that's stuff that can go into BMP records. Of course, say for outbound dropping, of course, there will be no BMP records, and either something like your record kicks in, or actually, for me, it would be sufficient to have the exit code marked in the internal table, and I can pull it out there for occasionally generating the report.
So thank you for the information and ideas you have here. As I mentioned to you privately, I want to mention the same comment. So pardon me if I repeat my advice, but I think after the rest of the discussion may be helpful. One of the things for some of the actions that Rudiger just described, you might do and use the new functionality for NetComp's push of information based on an action. I just simply encourage you to look at those options, because I know you're serving customers and you may want to look at it. Part of the problem is we haven't moved the BGP Yang models quickly, but we need more eyes in review. So perhaps this is a double plea. If you think that Yang models are better for telemetry or some of the push mechanism, if you don't know what the push mechanism is from Yang, that's an ability to push out telemetry or information based on information. That may fit some of your things. It may fit some of the customers. I simply note that something like Rudiger suggests could be an action that then resulted in reports going out to multiple clients. It's just another thought to choose between. And I thank you for your willingness to let me repeat the advice.
Thank you for the suggestion. I think it's, we should do some comparison and analysis of different options. Yeah, that's a good suggestion. Thank you.
Hi. So it seems like you're trying to solve two different problems here.
Who are you?
Igor Goshinsky, Yahoo, Verizon, Media, whatever.
Sorry.
It seems like you're trying to solve two different problems here. One is a problem of what actually happens when the route is received to it, whether it's accepted or dropped. The other one is why. What you could almost get from just nothing but comparing BGP rib in and like lock rib effectively. The why is a lot more complicated than a single policy. At least on my network, we use chains, we use recursion, we use chains in recursion and recursion in chains. I have no idea how you would express that in this type of a message. What's more is we add communities, perform action, remove communities in a single policy, in a policy chain, obviously not in recursion. So to Jeff's point, this level of debugging is incredibly useful, but I don't think you can encode enough of it into a BMP message like this, some other form of like basically trace option type equivalent or like GDB. Like this is actual debugging info where that's great that you exited on policy X, but I have 7 terms in there. 3 of them call other policies that have 17 other terms. Like honestly, I just need a dump of every value that you came in and the action, and then we'll debug how the hell those values came in there. I just don't see how you can make it useful enough to put all that in BMP. But what happens, like accepted or not, that's useful, but then I'll just compare the 2 tables. The one thing that wouldn't do is the reason for rejection, like in Rudiger's case, but I'm willing to bet that you have the same issue where you have chains, you have subroutines, and like you need to know at what point the exit code happened. And when you're doing recursion, do you pop out the bottom exit code, the top, all the exit codes in between? Things get funky. So I'm not sure that you could actually get this via this.
We are not doing that much complexity. And if you get the chance for marking the decision points with something that you figure out will be meaningful for you, you may actually change some of your policy to omit the specific reason in certain cases where at the moment it is all unified. Because, well, okay, you don't know, and it doesn't matter. You want it dropped, and if you have a chance to know it has been dropped because of circumstance A versus circumstance X, you may actually end up with splitting some of the code paths for just supporting that.
Right, but for us to do that, we would want a stack trace. That's effectively what we want. Dump a stack trace. And that doesn't seem like this is useful for that.
Yeah, well, okay. The stack trace is something where you are really debugging, while my use case is a little bit more. I'm actually trusting my policy, but I want the information that I can meaningfully give my customer, the peer, about what I figured out is wrong. So that is kind of debugging at local level versus interdomain.
Right. Well, I mean, so give you a clear example of policy. We have a chain that says strip bad communities, block bad routes, set local pref, do something else, right? That's a pretty typical chain. And then block bad routes has a bunch of terms in it that say, are you invalids? Are you too small prefixes? Are you IANA reserved? Like a bunch of stuff's in it. The block bad may exit because of term 3, which is you're trying to semi-default, and that's block bad. But do you pop out that the policy that did it is block bad? Do you say that it's ingress? Do you say that it's term 3 of block bad? Is it block bad because you've sent me an invalid community on it that we specifically told you not to? All of this is actually meaningful information if you want to send the customer why. And I think for that, you need a stack dump. I mean, so there's people that you don't need that for, but then there's people that use recursion that would need that. And I don't think you want to build a protocol that basically says anybody that's doing anything even remotely interesting with your policies, you can't use this. So I'm kind of torn whether this actually belongs in BMP or not. We need this, absolutely. I just don't know if this is the best vehicle for it.
Okay, so I'll explain a little bit about how I design the current policy format here. So for Huawei devices, typically we don't use recursions under the root policies. So that's typically just a root policy for each peer or each peer group, and then there will be multiple it's called nodes under the root policy, and then under each node there will be if match and apply sentences. So it's not like recursively policies. So from that perspective, I think if I give the policy name and the node ID to this extent, I think that's sufficient. But I haven't considered other situations. Yeah, we can definitely look into those other implementations and see what we can do. Yeah.
Job Snyder's NTT. I would like to echo that this seems very interesting to obtain more visibility in why the network behaves the way it does.
Okay.
A concern with this version of the proposal for me would be that it may be challenging to correlate the BMP messages with the policy that existed at that time on the box. Let's talk crazy. If I'm sending a new policy to my router every 10 seconds and BMP messages come in with the metadata, it's almost as if I'm emailing somebody a GDB core file without providing the symbol table or without providing the binary. And that's a challenge, but we don't want to put those symbol tables in BMP itself.
Sorry, I didn't quite understand the question. Can you like explain a little bit slower or another way?
When you send a BMP message to the collector that has the policy ID and the node attribute or node ID, it may be hard to correlate what the actual policy at that moment on that box was. Because if I'm sending a new configuration to the box every few seconds, then I don't know which version of the policy was in use when the BMP message was created.
Oh.
So that's something that I don't immediately know a solution other than to put policies in BMP. So that's one approach where basically you propose to create a stack trace that can be very valuable. If we make an analogy with the Unix world, another approach to increase debuggability of this information is to allow for locally significant exit codes, where we do not attempt to pinpoint this line of the policy was what caused it, but this is just the reason it was rejected or accepted. And that approach may actually be a good fit for BMP because there is no dependency on knowing what the exact policy at that moment in time was. And it may be easier because we don't comment on how policies are constructed. We just comment on the outcome of the policy. And it will be up to the operator to say, value 1 means it was rejected because it was a bogan. Value 640 means it was accepted because it was made it through the entire policy. But that will be up to the operators. So, yeah. Anyway, I'm very interested in this work, so I would really like to encourage you to continue working on this.
Yeah, thank you. And one more thing I forgot to mention that I think, yes, adding the outcome of the policy processing to the message is important because sometimes a policy is processed incorrectly, but it doesn't change the attributes. Then currently in this version, it's not recorded. But yeah, it should be. So yeah, the outcome should be added into the message.
Thomas Graf, Swisscom. I think as well it's very important that we get visibility into route policies. I think with
Closer to the mic, please.
Yep, sorry. I think with adjacency rip in, with the local rip, adjacency rip out, we know exactly which prefix, which attribute we have in which rip. And now with this information, we get basically when and the where, at which route policy and at which time. What's very important is that it's well aligned with the BGP Yang model, so that we can take a reference basically to the configuration of the Yang policy. I think the Yang policy configuration shouldn't be part of BMP, but BMP should be able to reference on the Yang policy.
We'll do that.
Yep.
Thank you.
Thank you.
So if no more comment, next draft. All right, so this is the enhanced AS loop detection for BGP. So nowadays, root leaks, root hijacks happens now and then. Here's an example that shows, in fact, let's just look at the left part of the figure. So 4134 is an AS number that belongs to China Telecom. And, well, is it okay to do that? Yeah, well, this is an route that AS4134 receives from other ASs. So some other ASs incorrectly put AS4134 at two options. The first one is the rightmost, which is origin of the AS path, and the other one is the transit position of the AS path. So both cases are the forged AS passes, and it could be utilized by some malicious attacks to lead to the results that block or to block the route from S4134, because when it receives the S pass and detects a loop, it will drop the route. So in this draft, we propose a enhancement to the inbound and also outbound policy to analyze such AS passes when there's a loop detected. Okay, let's look at the two examples. So for the inbound policy, currently, when a loop is detected, what we do is simply drop it, and also maybe we'll withdraw the route if it has already existed in the FIB. So it is utilized in some cases to block certain ASs from contacting other ASs. So here we propose to do a further check. So S20 will check the AS path to see if itself, for example, if it's placed in the origin position of the AS path, and then you can do the ROV to see if that prefix belongs to itself, or if it's placed in the transit place, then you can check the business relationship with the ASs that is next to it, to the left and to the right. So, for example, in here, 200 will check its relationship with 300 and 600 to see if they are in the right place. So, this kind of checking does not need any business relationship referring, but it's only limited to certain hijack checks. So it's not covering all the cases. Yeah, but yeah, it can sort of it can find out some hijacking cases. So that's the inbound policy enhancement. And for outbound, similarly, when a AS loop is detected, it will check again the AS relationships locally and see if there's some unusual things happening. And yeah, for the next steps, we're going to do with this draft is that we want to add some suggested actions when detecting different type of unusual things. Yeah, and that's that for this draft.
Rüdiger Volk, Deutsche Telekom. I am sorry, I did see that there was quite a number of mail messages and I did not work through that. When I'm seeing what you are addressing there, I wonder whether you are aware of the ASPA being developed in Cider Ops.
I don't know the details, but I heard it.
Yeah, well, okay, kind of for doing AS path filtering, I certainly would suggest look into that. That may be a very good source for feeding into the policies that you want to run. I cannot tell whether you are attacking more than can be done by ASPA, but ASPA quite certainly is a very solid concept. And the information base that you will get that way will be very trustworthy. So that's something that should certainly not be ignored.
Thank you.
Job Snyder's NTT. Again, very interesting material. What I was wondering, if we know that it's not a regular AS path loop due to a route leak, but it's a forced AS path because, for instance, it failed the ROV check or it's an impossible AS adjacency in the AS path, then what? Because in none of the cases we want to accept such a route anyway, I would think. So the only follow-up action that I can envision would relate to your previous presentation, where in BMP, for instance, it's marked differently as malicious AS path loop rather than.
Very good suggestion. I to be honest, I don't have very clear suggested next steps right now, but I think maybe checking using the root policy record to see what's happening further is a good idea.
Potentially, this can empower networks to more easily identify that they are being victimized in one way or another. But yeah, that would mean this would depend on your previous draft, so it can signal that this happens.
Thank you.
John Scudder. Do I correctly understand that basically what you're proposing to do is detect path poisoning attacks? Are you familiar with that term?
No.
Somebody who's familiar with the term able to say, I'm on the right track?
Yes, that was the first thing she showed, was a path poisoning attack.
So it is path poisoning attacks. Okay, thank you. And I guess...
So actually, that's one thing she showed.
Okay.
It's not clear exactly what the set of requirements that are being aimed at here is, which...
Yeah.
If I was going to make a comment, it would be that. It would be
right.
Please.
That's kind of what I'm trying to understand is what we're fixing. But and then the sort of semi-related follow-up, I guess, is that it seems like a lot of this could be addressed probably already today by just looking in your routing table to say, show me all of the looped paths that have been not selected because they're looped, and sort of in an ideal world, you should be able to take that and analyze it offline and find the weird stuff. So in other words, it may not be necessary to go and change the protocol or the implementation in order to allow operators to analyze their tables to see this stuff.
Yeah, thank you. And yeah, right. You're right. We're not changing any, I think, protocol here. And I agree that there has been some works done to do such checks, but probably maybe listing some possible cases or those things will be more helpful.
Jeff, so John, the path poisoning was a use case I suggested, but it was not originally part of their core use cases. To restate what I see out of the draft, really what's there is a taxonomy of the different types of looping conditions based on what you see in the path for your own AS. And aside from the fact that they're currently numbered use cases, there's still a useful taxonomy for analyzing what type of loop you're seeing, being able to have this in your route output. For example, our implementation shows you why a route failed to be installable. For example, AS loop is one of the conditions. This is effectively a sub-condition of an AS loop. Being able to see in a consistent multi-vendor fashion what kind of loop this is a useful thing. Where I'd expect this to eventually show up after the work has become a little more mature is like in the Yang model for BGP, adding a new field in there that allows you to see basically a route accept or deny condition, and this would be a list of conditions where it would be denied for looping considerations.
All right, thanks.
Sorry, Chris Morrow, Google. I think a list of requirements would be great. What are you actually trying to do here? And if, like, so as Job said, like, so you get this route, what are you going to do? Drop it, accept it, do something else with it? Like, that should be part of the requirements. I want to do this thing so I can agree to accept the route, or I want to do this thing so I know I absolutely should not accept it. And then also Job's comment about it'd be good to get this into the other draft or something like that to say why this happened, which is, I think, actually Jeff's comment too, right? Because this gets logged in with a special code so we know. I didn't see that really in the draft.
Yeah, in fact, I think the enhancement we propose here is not about whether to decide we should drop or accept the route, but to further understand what's going on, more about that. Yeah.
Alexander Azimov, Yandex. Two comments. First comment, positive. It's a good thing to be able to have internal alerts if you are seeing something weird with your prefixes, and so your peers are sending you routes with an IS path in which is your own autonomous system. Mm-hmm. But such a detection heavily relies on a precise list of agencies. And there is a problem, and the problem is access, which are not present in the path. And there is a lot of indirect agencies there. And you are not easily there is no way to easily retrieve them, at least for not all access. So there is my comment.
Thank you. Maybe we can discuss offline a little bit more. Yeah, I didn't quite get your comment. All right. Thank you.
Thank you. This brings us to the end of the growth session. Is there any other business? Speak now or stay silent until IETF 105. Or the mailing list, or in person, or in the hallways, or Jabber. All right, that's it. Thank you for attending. See you in a few months. The two people I was looking for.
We're supposed to talk about something that's in your tree.
Yes. Failed attempt to silence me in right.
You want it could be an idea.
So I think Sriram's comment or question was, should this be moved from IDR to grow? Number one. And number two,
are we talking about next week?
No. Okay. We'll first. So that's the first step, and then should this end up having to go back through the adoption process, or just come in as a work group?
Yes.
The route that he came back to said